Okay, so section 5.3 is going to be broken up into 3 videos, 1 video for each objective. None of the objectives will be that long, so you can choose to either watch all 3 videos at once or you can split it up over the next few days. But this particular video is going to talk about objective 1 only. So the 3 objectives altogether are going to be to identify independent events, to use the multiplication rule for independent events, and to compute at least probabilities. So again, this video is going to concentrate on objective 1 only, and that's to identify independent events. So 2 events, E and F, are independent if the occurrence of event E in a probability experiment does not affect the probability of event F. So for example, if I have a baby, it's either a boy or a girl. If I have a boy and then I flip a coin, it doesn't mean in any way, shape, or form that I'm going to definitely flip a head when I toss my coin. So the probability of one in no way affects the other. 2 events are dependent if the occurrence of event E in a probability experiment affects the probability of event F. And the best or the easiest example of that is if you are doing probability without replacement. So if you have a bag of green marbles and red marbles, and you have 5 green marbles and 2 red marbles, and you want to know the probability that you pull green on both pulls, the first time you stick your grubby little paw in the bag, there's 5 green out of a total of 7 marbles. So there's 5 out of 7 chance. But the second time that you go to stick your hand in that bag, you have to assume that you have a green marble in your hand right now, which means there's only 4 left to pull from for the green. And because you have 1 in your hand, there's also 1 less altogether. So it will be 4 out of 6 the second time around. So that's dependent. So first few that we're going to do here is just identify whether it's independent or not. So does one event in any way, shape, or form affect the probability of your second event? Suppose you draw a card from a standard 52 card deck of cards and then you roll a die. So again, would pulling your card have any effect on what you roll on your die? So if you pull a king, are you definitely going to get ahead when you toss your coin? The events draw a heart or roll an even number are independent because the results of choosing a card do not impact the results of the die toss. How about the events earned a bachelor's degree and earn more than $100,000 per year? These events are not independent because knowing that an individual has a bachelor's degree affects the likelihood that the individual is earning more than $100,000 per year. It doesn't mean that it's definite. It just means that it's more likely. It definitely affects the probability. So that is dependent. Part C, event E is speeding on an interstate and event F is being pulled over by the police. Dependent or independent? That's going to be dependent because speeding on an interstate increases the probability of being pulled over by a police officer. Again, it doesn't mean that you're definitely going to get pulled over, but you're definitely increasing your odds if you're doing above the speed limit. And suppose 2 40-year-old women who lived in the United States are randomly selected. The event woman 1 survives the year and woman 2 survives the year. Okay, so if one woman were to pass away, would that in any way, shape, or form affect a second woman living or dying? Very morbid. The events woman 1 survives the year and woman 2 survives the year are independent. Again, if one woman survives or God forbid passes away, that in no way, shape, or form is going to affect the second woman. Suppose that you flip a fair coin twice. What is the probability that you obtain a tail on both flips? That is a tail on the first flip and you obtain a tail on the second flip. So the first thing that we're going to do is just look at all of our possibilities here. So I can toss a heads and then a heads. I can toss a heads first, then a tails, or I could toss a tail, then a head, or I could toss a tail and a tail. So again, we want those are the only outcomes when you toss two coins. There's no other combination of heads or tails that you could have. So you want a tail on both flips. That's one possibility out of a total of 1, 2, 3, 4. So you have a 1 out of 4 probability there. Okay, which is going to lead us right into objective 2. But again, objective 2 is going to be in the next video.